Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show. Karen, I hear that today we're going to finish up the mini pinball kit.
Oh yeah, we have reached the end. Whatever we're gonna do with the mini pinball kit, we're doing today. Are you ready, Ben?
Yes. So we have it physically done. We just have to create some art, sound, code, scoring, and then test it.
Yeah.
Let's get started.
Amazing hacks.
Should we take it for a spin?
Inspired designs.
Imhotep's priests.
Regrettable acting.
No one seems to get it.
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Okay, I've been doing some design here for the semi-generic playfield. I created a slope for the ball to launch out of. I designed that in Fusion 360. It looks like this. So that'll be pretty cool. So there's some tabs on the side of this. See here and here, there's 4 tabs. Those tabs will be held in place by the launch rails. See these guys here? So you can see the openings for the tab. So basically you'll just set that 3D printed piece in place, then you'll snap these walls in place and they'll hold down the ball launch. All right, I've made a few adjustments up here. We still have the same spacing for the outer perimeter, and you can have like a large curve with a 2-inch diameter radius, or you can have a small curve like this. And then we'll include a bunch of these snap-in pieces here. And I did change it a little bit where they will butt up to the edge of the next piece. So a few slight tweaks, but not much major. So then what I did was I made an array of all of these peanut butter cup shapes. And then I thought, okay, well, what is the distance we need from the inside of the playfield? So I basically figured 0.75 inches would be good. So the center of these peanut butter cups here on the right, they will be centered the same as the launch lane. So if you want to extend the launch lane, you could. Or if you want to have, an orbit that comes just below the launch lane, that would work as well. And we also have them on the other side here. So you have plenty of room for left and right orbits for the ball to travel. Yay. Also made several different pieces. So we have a 2-piece, a 1-piece, sounds like I'm talking about swimsuits, a 2 wide, 2 close together. Yeah, and then basically if you put all these together, you can completely enclose the playfield as far as the outer perimeter using the tabs, and then create your inner walls using these Reese's peanut butter cups, which is a great technical term for them. I've also added the kind of sling rubbers. Now, just like the mini space shuttle, these will just be posts with rubber bands around them, but they should give you some bounce. So I have some up here, the upper ones, and those will pretty much be static. And then the ones just above the flippers. Yeah, that way the ball has a chance to drain, but it's not going to be too brutal for the player. And we could always tweak the height of those if we need to. Or we could even, like, in the kit, there could be 2 sets of holes. So there could be another set that's a little lower to make it easier, making the opening smaller, and another set of holes that's higher to make it harder. Something else I need to think about as well is the optosensors, maybe staggering them within these slots. Yeah, so in that case, it's a question of, like, if the wall is here and the ball is here, where could the ball interface with the sensor? I think I have a drawing of the sensor down here. So in this case, we could put the sensor probably right about there, but if there's a gap for it, we have to make sure that it doesn't get too close to the peanut butter cup, because then there wouldn't be enough mass in the wood right here for it to stay stable. All right, I've done some more designing here. I figured out where I could fit one of these optosensors between the peanut butter cups, and I'm just going to keep calling them that. 45-degree offset seemed to make more sense, because if the ball's rolling against a wooden wall centered on the peanut butter cup, then that means the best offset is actually between the peanut butter cups right there, this slit. So those slits, those would be in the acrylic layer. If we had a preset game, it would only have the slits where necessary. Whereas a kit, there might be a bunch of slits with perforations and you just punch out the ones you need. I think we could make a PCB of this. So we'd have 3-pin connector, which would go back to the main board. and then the opto sensor. We could also make like this to be dual purpose. Like if you flip it around, maybe there could be an LED. Of course, the LEDs, you'd probably use these spare peanut butter holes for your insert lights. I didn't completely fill it up with them because I don't want to like ruin the structure of the wood. But I have 2 on the orbits, which should be pretty good. Then I have staggered units here and here. So what it would actually look like when you cut the wood is it would look like this. So these would be your options. Okay, here's a full-scale printout of it. It just barely fits inside of a piece of paper. Yeah, so I'm just going to take a look at this and make sure that it makes sense with the physical walls, and then I'll continue the design. Getting pretty close to the point where I can laser cut a generic playfield, and then I can actually design a custom game onto that. And then by having the art layer only have holes in certain places, that's what actually would make it custom. So even though the playfield has a whole bunch of holes in it, we'll only use the ones that are necessary for the design that I make. And the reason why I don't put these optos everywhere is because there's only so many ways you can shoot the ball. I mean, there's not a huge point to having an opto right in front of another opto if the ball's going down a path. I think this should probably be enough. I mean, I could add one more layer just to be safe, but you know, it should probably be okay. So it looks like we're going to have to use those larger solenoids for the flippers. And basically, it's just making it longer by about exactly 0.7299 inches. All right, so what I'm going to do is I'm going to take that measurement and I'm going to go into Fusion where we have the original drawing. So let's chop this up. It's probably going to complain about things, but I don't care. I need my pain. Yeah, I just quoted Star Trek 5. What are you going to do? Okay, so I'm going to come out from that. Let's get the angle matched up here. There we go. 0.7, just do 7.3, close enough. 7.3, get the angle. See how I'm kind of going back on it to kind of get the angle stuck into memory. 7.3, 7.3, and come over to pow. There we go. Now, not so long ago, they added sheet metal into Fusion, which is pretty cool. So I was thinking we could use that to design this exactly how it should be made. Let's see, I think you have to go into, oh yeah, you have to switch over here. Model, sheet metal. Okay, now we have to go into sheet metal rules, which are kind of like cider house rules, but Tobey Maguire isn't there. Oh look, here's a website with all the measurements for steel gauges. Okay, I'm gonna grab 20 gauge right there. All right, so let's take this steel and let's basically make a new rule based off of it. Steel, 20 gauge. Okay, the thickness is going to be that many inches. K factor, I'll do 2.25. You can always come back and change that later if you need to. All right, so now we have a 20 gauge steel rule for this. So now we can actually do things with this and it will basically follow those rules. All right, so now that I have all this, I can go in here and also I gotta select the right one of these. Let's see, so that one's 0.48, so that means I need this outer circle here. That's the proper opening. So let's grab that, grab this, and then we're going to create a flange. And we're going to create the flange using our 20 gauge steel rule. So you don't actually tell it an extrusion thickness, it just knows what rule you want to use. Now what I want to do is I want to bring up the sides of it. So I'm going to come in here, I'm going to grab these edges, and I'm going to make more flanges. But since these are edges, it will make them curved, bent sheet metal flanges. Watch. So in sheet metal, you have to take into account like the bends and whatnot. Yeah, see what that did there? It was like whoop, and it came in. Now, we can't go in, we have to be on the outside, otherwise it won't fit. So we're gonna tell this to be a outside, yeah, I think outside is the way to go. Okay, and the distance is going to be the value we pulled from Illustrator. Now we see this little dimension here that shows the distance. That should go from the top of the flange, or the top of the flat piece that we first made, to the top of this, and it looks like it does. Okay, that's cool. All right, so those are the walls that are gonna hold the solenoid in place. I'm gonna do the same thing over here for these pieces. And these are the end stops for the linkage. I'm trying to remember how tall these have to be. Not very, if I recall correctly. 0.6, all right. Same thing, flange. Let's see, outside, yeah, same settings, 0.6. Cool. Basically, we're drawing this as sheet metal that's been bent. But the real cool thing is that when we're done designing this, it'll flatten everything out. All right, so I'm gonna add some mounting holes for the solenoid here, and then we can flatten it out. Here's the cool part. Modify, create flat pattern. Pick the base. Blammo! It's a flat pattern design of our base. Wow, it even shows us where the bends are. Pretty cool. Yeah, so the idea with this is if we have enough holes, like for either way, basically the way you bend this makes it a left or a right. But since the mounting holes on the side of the solenoid aren't symmetrical, we have to make 2 sets of holes. Okay, I can cut this flat pattern on the laser and we can test it out. All right, I've got all the art in place. We recorded some audio of the king who will taunt you as you fight him. So yeah, let's give it a try. Crank up the tunes. Here we go. So as you attack him, he'll complain about you know, killing his archers or wrecking his catapults. I know, we should do a 4-player game with all of us.
See, I'm always third. I'm gonna keep my bronze medal.
Come on, no, Uh-oh. I expect it to bounce more.
Is there a sanitary place for me? All right, I'm just gonna put my cookie in my mouth.
Where else would it go?
Well, I'm not done eating it yet, but I don't want to finish it yet. Ah, dang it.
Good night. He's tired of being a jerk, so he just sleeps.
We should have made like Marie Antoinette pinball, like a guillotine. And it could be like Kristen Dunst, who's terrible.
Oh, she's so ugly.
I know, God.
Ugh.
I was watching that one movie, Bring It On, and I'm like, oh, why did they let her in this movie?
And in Spider-Man, I was like, this ruins the movie for me. I can't even watch it.
She's not even a real redhead.
It should have been Gwen Stacy. Wait, so is Bryce Dallas Howard actually a ginger?
No, I think she is.
Oh.
Yeah.
So they made Kristen Dunst into a fake ginger, and they turned a ginger into a blonde. That's ginger washing.
That's weird.
Ginger washing.
Why would they do that?
Because Gwen
Go
Stacy
up
is
there.
blonde.
There's a ton of blonde actresses, though.
That didn't even register.
Yeah. Oh, wait, they could have had Charlize Theron in it.
Yeah. Or they could have switched those two roles.
She's not a ginger.
She's
Although,
blonde.
I don't like Bryce Dallas Howard, so.
Wait, for what movie does she need
Spider-Man 3. We're recasting Spider-Man 3.
Yeah.
But it's not Mary Jane.
No, because Mary Jane is Kristen Dunst.
Don't need to recast her.
Yeah.
Dude, I don't remember Spider-Man 3.
That was the one that sucked.
Yeah.
Oh, that was the one with like weird emo. Spider-Man, where
Yeah.
like Tobey Maguire's all like.
And then there's that newscast that's
Walking down
like,
the street.
the third act is starting now, and we have to explain a bunch of things that we didn't
Max.
explain before. Yeah,
Oh,
that's
wait,
me.
so you're player 4, right?
Oh, I think we lost track.
I'm always
it.
player
I thought
3.
Max was 4.
All right, Max, go.
Oh no, wait.
Yeah, I'll do.
I was after you, because I think you
yeah.
just took Felix's place.
I'm always player 3.
Yeah.
Yeah, because Charlize Theron is, like, all those actors are the same age, which is the same age as me as well. So,
Kristen Dunst?
no, Kristen Dunst is younger, but like Tobey Maguire, Bryce Dallas Howard, he's my age. Yeah. Well, Karen, we finally finished the mini pinball kit prototype.
We did, and it's super fun to play. I kind of don't want to stop playing it. Maybe it's just because I am so terrible at it. I want to at least like try to get kind of okay, not even good, just kind of okay at it.
Right.
So, well, since it's done, why don't we look back at what we originally set out to do and see how the final prototype lives up to that?
Yeah, we have the original document open here on the laptop. So an early thing we did was we chose a microcontroller. What did the system need to do? One channel of sound effects, one channel of music, video, LED, LCD. We also had here, what's the cheapest way to display information? And your standard Hitachi 16:2 dot matrix display is maybe not the cheapest, but well, it's pretty cheap. I mean, I think that's like $15. It's not
That's
too
not bad.
Not too bad. Also, you can drive that with a wimpy little Arduino or a Teensy. Like if we would have had an LCD screen, it would have required a much beefier microcontroller to do. And we kind of ran into that when we did the Logic Gate board game. Remember that project? Yeah,
Yes,
the
I
project
do.
that eats souls.
Yes. Well, and so you were talking about how it would need to drive lights. I forgot about that, but you originally wanted to try to put lights on the playfield, and that's why we were originally going to try to use acrylic, which we have since abandoned. But
Right. Although I bet you
yeah,
can shine
you
light
could
through
probably
the
shine light
holes
through
are
there.
still there.
Yeah, I
Yeah.
think you could make it work. So the functionality is there, we just didn't do it yet.
Failure, the greatest teacher
Ooh,
is.
actually, that would look super cool.
Yeah, that's not bad actually. So this is just, I want to say it's like 50-pound photo paper. I got this printed at FedEx Kinko's. It was like $3 to print this.
Yeah, an 11 by 17, so
Yeah,
people
not
could print
bad.
these themselves and just trim them out a little bit. We obviously use the laser cutter to cut the holes for the optos and the supports for the walls, but I mean, you could do that with an X-Acto knife if you drew it out well enough.
Yeah, and the art, you could match up the art to where you know the Reese's Peanut Butter Cup holes are, and then you could have indicators.
Yeah, so someone could absolutely do this at home. All right, designing the mechs. Oh yeah, we originally were looking at how we could do
Pop bumper.
and targets.
And I think that was mostly it. It's pop
that was
bumper and a
pretty much it.
target. And we have the two flippers. We tweaked those quite a bit. I know a few episodes ago we were redesigning that a lot. The ball loading mechanism is pretty straightforward. It's just a rotational wheel with a limit switch hooked up to a servo.
Yeah.
And we have 4 servo ports on this, so you could also have toys and things in the playfield using servos. One issue we came across is by having a modular playfield with all these peanut butter cups, it works really well for walls, but then it kind of limits what else you can add.
Yeah.
Although covering the holes with the paper worked really well.
Yeah.
So we used some of the original code from Super Space Shuttle. That was on a Teensy 3.1. This is a Teensy 3.6. We used the built-in DAC, the digital to analog converter, so we didn't need that audio shield or whatever we had it on originally.
Oh yeah.
Yeah, so we just created a state machine in the code that says, okay, what's the state of the game? Is the game in attract mode? Is it active? Did the ball just drain? So most of that is handled basically by the main library. And then if you're making your own game, you just have one section of code, one function that's called every cycle, which is basically like, game logic. And that's like, are the targets hit? Did you drain? How many points you should get? Everything else is handled for you automatically. So if someone's making their own game, they only have to modify the code in that one section. They don't have to worry about how the rest of it works.
Well, and that's good because that way if they're only modifying that one, if something accidentally gets messed up, then they don't have to worry about trying to reset everything. Like the game will still work, they'll just have to redo that little bit of code.
As long as they detect a ball drain, everything else in the loop will work, like adding players and terminating the game and all that stuff.
Well, I don't think we're going to kickstart this or produce it in any way, try to have it manufactured, but I think we can at least put our design files on the Element 14 community so that people can try to hack it themselves. What do you think?
That sounds fine by me. Yeah, as opposed to like the Hex game or even like the Raspberry Pi Portable, where those things are basically just a circuit board.
Yeah.
The circuit board is only one component of this. That's also a fairly large circuit board, so that wouldn't be super cheap either.
So tell us what you think of our final version of the mini pinball game. What would you have done differently, and how would you hack this kit if you had the chance to do it at home? Tell us about it on the Element 14 community on element14.com/TBHS.
You can also go there to read about other upcoming episodes, builds, and special events. We'll see you next time. Past a certain distance, like hitting water, you may as well be hitting concrete.
You know what? I could survive.
Not necessarily,
I could
unless
do
you
it.
died.
I could figure it out.
You getting out the Thin Mints?
So every year on the Ben Heck Show, we get a box of Thin Mints. And this is the last one.
Oh yeah.
Oh yeah, the last box or the last year?
The last year.
I think
End
you're
box.
next.
Yeah.
Crash my plane, Stephen. I need some more money so I can buy a new plane. And as long as you keep Alien Day in your heart, the magic of Christmas will never leave you.
My MakerBot works great, but another friend of mine gave me his old broken MakerBot. It's been sitting up on the shelf, basically taking up space, but now Felix wants to repurpose it into something.
I'm gonna take it and put a USB microscope on it.
So Felix wants to make this project using the BeagleBone Black. So we thought, who better to talk to than Jason Crinder, the father of the BeagleBone Black.
Let me see if I can figure out how to assemble this. It's like a jigsaw. Hiya!